Look, if you're losing marks on practical data questions involving mass, weight, density, pressure, and resultant force, you're definitely not alone. But today, we're fixing that entirely. Let's immediately upgrade your last-minute revision plan into a top-band scoring system for your Cambridge IGCSE physics exam.
Take a look at this flawed student answer. Notice what's missing? No units, super vague explanations. Doing the math in your head and skipping the required steps literally scores 0 method marks. It's exactly as bad as leaving the page completely blank. The examiner has absolutely no choice but to give a 0. Guys, this is a grade boundary disaster just waiting to happen.
Now you might be thinking, I'll just memorize the chapters. Well, memorizing textbook chapters like density or pressure simply won't save you if you don't know how to extract the exact variables and equations when you're hit with practical data questions. Knowing the formulas? That's just step 1. The real exam tests your ability to navigate specific danger zones by applying those formulas to raw, messy data.
So, why exactly does ordinary revision fail? It usually comes down to these specific grade-destroying mistakes. We're talking missing units, rounding way too early, and giving vague explanations instead of using precise physics terminology. Throw in graph axis errors, weak practical improvements, identifying the totally wrong variables, and writing unsupported conclusions. Honestly, committing even one of these 7 deadly sins can easily knock you down an entire grade band.
Okay, to stop losing those marks right now, we use this 4-step strategy. It's absolutely foolproof. Step 1 is concept. You state the physics law or equation. Step 2 is evidence and data. Pull the exact numbers from your source. Step 3 is scientific reasoning. Logically connect that raw data directly to the physics. And step 4 is examiner wording. You format your conclusion exactly how the mark scheme actually wants to see it.
Now, in a moment, I'm going to show you the crucial examiner clue that changes a failing answer into a top band score almost instantly. But first, you need to see how this framework makes that specific clue totally obvious. Because without the framework, you honestly wouldn't even know where to place this golden piece of information. Let's break down exactly how steps 1 and 2 actually work together.
All right, start by stating the key definition or equation using correct physics terminology. For example, explicitly writing density equals mass divided by volume. Then, immediately back it up. You need to pull exact substituted values with their units directly from the source data. Don't just vaguely write, the mass is bigger. No, write, the mass is 50.5 grams. Your evidence absolutely must be concrete, numerical, and extracted right from the provided info.
Next up, you fulfill the command word by connecting that data to your scientific reasoning. If the question specifically asks you to explain, you have got to link those substituted values back to the core concept. Finally, you utilize exam-safe wording to lock in those method marks. This means using phrases like directly proportional or limit of proportionality, rather than just saying it goes up at the same time. Exam-safe wording basically proves to the examiner that you're totally fluent in the language of Cambridge physics.
Okay, let's see how this all builds up in a real scenario. I want you to pause and predict right here. Look closely and see if you can spot the hidden trap in this typical student calculation for density and pressure. The student wrote down the numbers, did a quick division, and got a final decimal. Take 5 seconds. Look at the math. Look at the final statement. What is missing?
And boom, this brilliantly illustrates the exact difference. The flawed answer on the left rounds way too early, which completely skews the final result, and they totally forgot the standard units. Is it pascals? Is it newtons per square meter? We literally have no idea. Meanwhile, the improved top-band answer uses the exact source evidence, maintains significant figures throughout the working, and finishes with perfect terminology and units. It clearly, step-by-step, walks the examiner through the concept, the data, the reasoning, and the final answer.
Now, applying this framework to a much harder practical scenario is where things get really interesting. When dealing with chapters like forces acting on solids, we absolutely must focus on apparatus, safety, and table design. Like, if you're asked to design an investigation to find the spring constant, your answer has to detail the specific measuring instruments, exactly how you'll ensure the ruler is vertical to avoid parallax error, and precisely what column headers, complete with units, will go into your data table.
Before you even think about turning the page, you have got to perform these highly recommended accuracy checks. Verify your units, check your significant figures, review your graph scale, and double-check you've accounted for safety measures. And finally, just check the overall reasonableness of your physics. I mean, if you calculate the weight of a tiny wooden block to be 10 million newtons,
Yeah, you probably want to catch that error before the examiner does, because that is one incredibly heavy piece of wood.
All right, here is that exact examiner clue I promised you earlier. Read this carefully. You will literally bleed easy marks if you did not explicitly write down the substituted values in units derived directly from the source data. The examiner mark scheme is specifically hunting for those substituted values. If you just do the substitution invisibly on your calculator and write down the final answer, you totally forfeit the method marks. Show the substitution, show the evidence, secure your grade. It's that simple.
Now, this framework we've just covered is absolutely perfect for standard, clean data, but it leaves one massive, unresolved problem. How do you actually secure your marks when a massive anomaly threatens to completely destroy your practical investigation? Think about it. When your data points for pressure and volume suddenly spike and your beautiful line of best fit is totally ruined, how do you mathematically and structurally save your grade?
Well, to solve that exact anomaly issue, perfectly plot your reliability statements and get your complete revision map for this final stretch. You must watch our next explainer. Seriously, are you going to let a single unexpected data point ruin your A-star? Or are you going to master the rescue strategy? Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click the explainer right now and let's master that anomaly rescue strategy together.